Hey, welcome back to your favorite Math 126 course, Pre-Calculus 1. We're going to talk about solving some more logarithmic and exponential equations. So if we review, here's your logarithmic form, here's your exponential form of the logarithm. If log base a of m equals log base a of n, then m and n must be equal. Let's take a look here at solving some logarithmic equations. In this one, we're going to use the inverse. So what you want to do first is you want to isolate the logarithm. So we're going to condense this by taking that up here. So we got log base 5 of x squared equals log base 5 of 9. And if you remember, the log base 5 of x, its inverse is 5 to the x. So notice I have both of these are log base 5, so x squared's got to be 9. But if you're going to use the inverse to undo it, you got to go 5 to this side and 5 to that side. So it pops out the x squared. 5 to the log base 5 of 9 is 9, pops out that 9. If x squared equals 9, solve that. X is plus or minus 3. So now you want to check that. Does x equal negative 3? Well, we plug it back in. 2 log base 5 of x, which is negative 3, equals log base 5 of 9. Well, we don't have a log base 5 of negative 3. I can't plug in a negative 3 into my log base 5 of x because x has got to be positive. That's the domain there. So I can't plug that in. So that negative 3 is an extraneous solution, it's called. A solution that appears to be a solution, but it doesn't satisfy the original. Whereas we put the 3 in, and we're fine on that. Let's do another one here. Notice if I take log base 5 over to the other side, if I subtract one of these two terms on this left-hand side, I'll have 1 minus something, right? So I can't completely isolate the log base 5. So what we do instead is we're going to condense this. Since we got a plus between, and we're going to use that product property. We get x plus 6, x plus 2 equals 1. Now it's just one single logarithm. And we got a log base 5, so we're going to undo it with 5 to the on both sides there, and that'll bring that down, if you will. It'll undo it. X plus 6 times x plus 2 equals 5. Now we're just solving a quadratic, so we got x squared plus 2x plus 6x plus 8x plus 12 equals 5. Solve this quadratic. So we've got x squared plus 12x plus 7 equals x squared plus 8x, plus 7 equals 0. Go ahead and factor that. X plus 1, x plus 7. So x could be negative 1, could be negative 7. Plug the negative 7 in. Let's test that. Well, I plug it in right there and right here. And I have log base 5 of negative 7 plus 6. Well, negative 7 plus 6 is negative 1. I cannot take a log base 5 of a negative number right there. So that's automatically out. Throw the negative 1 in, on the other hand. Here, negative 1 plus 6 is 5. Log base 5 log base 5 of 5 here. Over here I got log base 5 negative 1 plus 2 of 1. Well, log base 5 of 5 to the 1, they don't show the 1 right there, is 1. And log base 5 of 1 is 0. And 1 plus 0 is 1. So that works. X equals negative 1 does satisfy the original, whereas negative 7 did not and was not a solution. Now here we got natural logs. You notice we got a minus between them, so again we're going to condense these. Keep the natural log of x over here. On this side we got x plus 6 over x minus 4. And both of the natural logs now are all alone. Who undoes the natural log? The ln of x. Well, e to the x undoes that. So we go e to this side, e to that side. So e to the ln of x is just the x. E to the ln of that x plus 6 over x minus 4 brings that down. Now let's get that x minus 4 up. Distribute that. So we got x squared minus 4x equals x plus 6. Subtract x and the 6. And we've got x squared minus 5x minus 6 equals 0. So x minus 6, x plus 1, x could be 6, x could be negative 1. throw those back in. Let's throw in the -1, x equals -1. Throw it in. Natural, what's the natural log of -1? You don't have a natural log of -1 because that domain is positive. That's out. Throw the 6 in. The 6 works perfectly fine when you throw that in. So make sure you're checking for extraneous solutions. And here with exponentials now. If you got a to the u equals a to the v, then u must equal v. Now in this case, they're not both the same base. It's not both base a, if you will, right? You've got a 5 to something, you got a 3 to something, and there's no way to like rewrite that 5 to the x plus 3. It's not like you can write it as a base 3. It's not like 3 squared is 5 or anything, right? It's 3 squared is 9. So there's no way to get these things to be the same base. So what you do is you got to just run. You got a couple options. You can either run log base 5 on both sides. You'll undo the 5. You can undo the 3 by running log base 3 on both sides. Your authors like to just run the natural log on both sides, so we'll go ahead and do that and stay consistent with them. And the reason that we do this is when you run the natural log on both sides, now you can use the power property. Okay, so that x plus 3 can now go down front. That 2x minus 5 can now go down in front. Make sure you put parentheses around that. Remember, this natural log of 5, this is just a number. This natural log of 3 is just a number. So you can distribute that number through. So you got x ln of 5 plus 3 ln of 5 equals 2x ln of 3, or 2 ln of 3 times the x minus 5 ln of 3. Okay. Now notice you got to get all your x's together. So I'm going to subtract this 2 ln of 3 times x, both sides, or maybe I'll write it this way, minus x times 2 ln of 3. Either way is fine on that. Get all your numbers on the other. So minus this 3 ln of 5. This is just a constant. Take it to the other side. So now we got x ln of 5 minus x times this number, 2 ln of 3, equals negative 5 ln of 3 minus 3 ln of 5. Okay. Now notice right here, both of these have an x in them, so I'm going to factor an x out. So I have ln of 5 minus 2 ln of 3 equals negative 5, and I'm going to factor a negative out of these, 5 ln of 3 minus, plus 3 ln of 5. Okay. Now at this point, see how we got our x all alone by factoring that out. We're just going to divide by ln of 5 minus 2 ln of 3 on both sides. Divide by ln of 5 minus 2 ln of 3. Okay, so this ends up being x equals negative 5 ln of 3 plus 3 ln of 5 all over ln of 5 minus 2 ln of 3. Okay, you can leave it like that. And you didn't have to necessarily factor that negative out, but you can if you want to on that. Those, and if you punched it in, here it is, but if you punch it in, 17.56 on that. Alright, what if you've got an exponential equation but it's quadratic in form? What do you mean by quadratic in form? So you've got something squared minus, so it's of the form ax squared plus bx plus c. Alright, quadratic in form, so it'll factor for you, ideally. So think about this 4 right here. 4 can be written as 2 squared. This is still to the x. Minus 2 to the x minus 12. Let me rewrite that another way. Since I'm just multiplying those, I could write it as 2 to the x squared. Alright. So this is some term. This is just like, so 2 to the x, notice I have a 2 to the x here and I have a 2 to the x here. This is exactly like x squared minus x minus 12, except instead of x, I have 2 to the x. Well, how would you factor x squared minus x minus 12? Wouldn't you factor it as x minus 4, x plus 3? right? Isn't that how you would factor it? So this will factor, instead of x, we have 2 to the x. We have 2 to the x minus 4 and 2 to the x plus 3. If you're not sure, just make sure you just check it. Right? You have 3 times 2 to the x, 3 times 2 to the x. So that's the first, right? Oops, I'm sorry. 2 to the x times 2 to the x. Oops, let me do it in order here. First, 2 to the x times 2 to the x. And then you've got the 3 times 2 to the x minus the 4 times 2 to the x, and then minus the 12. 12, my goodness. There we go. Well, 3 2 to the x minus 4 2 to the x is a negative 1 2 to the x. And this 2 to the x times 2 to the x is 2 to the x plus x, in other words, 2 to the 2x. In other words, 2 squared to the x, which is 4 to the x. So see how that factors? Well, that's just my check. So anyways, let me go back to this right here. We have this equal to 0. Now we're going to solve that. So if 2 to the x minus 4 would equal 0 by the zero product property, 2 to the x plus 3 equals 0. Add 4 to both sides. 2 to the x equals 4. Run the log base 2 right here. And you've got x equals log base 2 of 4. And remember, 4 is 2 squared. So you got log base 2 of 2 to the 2. X equals 2. Over here, subtract 3 on both sides. 2 to the x equals negative 3. Run your log base 2 to undo that. Log base 2, well, there is no log base 2 of negative 3, so this is out. So your only answer here is 2. Make sure you plug it back in and double check that. Alright, how about using a graphing utility to solve this equation? So you got log base 2 of x plus 5 equals 4. What we're going to do is we're going to let y equal this side. Log base 2 of x plus 5, just go to desmos.com, desmos.com. Then we're going to let y equals 4 on this side. So that's what I did here. Okay, so once you plug that in, and you'll get that, you click on them, and it'll give you this little point right here. You just click on that point that's in gray initially in your computer, and you'll see that that's where they cross right there. Man, why isn't this thing moving over now? Anyways, appreciate you watching. That's it for today. See you in class.